The southern San Andreas Fault has not produced a major earthquake in 335 years. Its average cycle is about 160. That means the most dangerous part of the most famous fault line in the world is now more than double overdue. By 2025, two separate studies landed within weeks of each other, both saying the same thing. When it finally breaks, it could be worse than anything California has planned for. One found that an earthquake 700 miles away in the Pacific Northwest could be the trigger. The other found that a fault, eerily like the San Andreas, just broke every model scientists had for how far a rupture can travel. 23 million people live in the impact zone. The water pipelines that keep them alive cross the fault 32 times. And every year of silence adds another inch of stored energy to a system already past its breaking point. This is the case for why the southern San Andreas is the most dangerous, quiet place on Earth. How does a fault go 335 years without moving when it is supposed to break every 160? The San Andreas runs roughly 800 miles through California, from the Salton Sea to Cape Mendocino. It is the border between the Pacific and North American plates. The northern part last broke in 1906. The central part near Parkfield creeps slowly. And the southern part, the one beneath Palm Springs, San Bernardino, and the Inland Empire, has been silent since before the United States existed. The last major earthquake on the southern San Andreas happened around 1690. We know this from deep test trenches near Coachella, California, where geologist Belle Philibosian and her team read layers of sand and silt like pages in a book. Carbon dating pinned the most recent break to roughly that date. The repeat cycle at that site averages about 180 years. Philibosian's finding was direct. The current gap since the last earthquake is longer than every quiet stretch in the record, not close to the longest. The longest. The person who put hard numbers to this danger is Yuri Fialko, a geophysicist at the Scripps Institution of Oceanography in San Diego. In 2006, Fialko published a study in Nature using 20 years of satellite radar data to measure how the ground on either side of the fault is shifting. The southern San Andreas is locked. The two sides want to slide past each other at about 1 inch per year, but friction holds them in place. The rock is bending, storing energy, and it has been doing this for over 300 years. Fialko figured the built-up slip gap at between 7 and 10 meters. The largest jump ever recorded during an actual earthquake on this fault was 9 meters. During the 1857 Fort Tejon earthquake, the current stored energy matches or beats that. Fialko described the southern San Andreas as 10 months pregnant. The United States Geological Survey's most recent earthquake forecast puts the chance of a magnitude 6.7 or larger earthquake somewhere in Southern California at 93% within 30 years. For the southern San Andreas alone, there is a 19% chance of that size event and a 7% chance of magnitude 8 or above. Those are not small numbers. And they were figured before either of the two 2025 studies that changed the picture. The 1857 Fort Tejon earthquake, a magnitude 7.9, tore 225 miles with a peak shift of 30 feet. It killed 2 people because California was nearly empty. A repeat today would cause hundreds of billions in damage. And here is the key part. That break stopped at Wrightwood. It did not unzip the southernmost piece, which has been locked since 1690. In 2023, a team that included Fialko published a follow-up in Nature that added a strange twist. The last 6 major earthquakes on the southern San Andreas all lined up with high water marks of an ancient lake called Lake Cahuilla, roughly 40 times the size of today's Salton Sea. The lake's weight helped push the fault toward failure. Co-author Matt Weingarten of San Diego State put it plainly. It leaves the southern San Andreas Fault locked and loaded. The lake dried up hundreds of years ago. The stress it used to add is gone. The fault's natural release valve has vanished, but the plate pressure has not stopped building. Not for a single day. And this is where the picture gets truly hard to read. Because what came next did not come from California. It came from a research ship off the coast of Oregon. In October 2025, Oregon State University marine geologist Chris Goldfinger published a study in Geosphere that linked 2 fault systems most scientists had treated as separate problems. The Cascadia subduction zone, running from Northern California to British Columbia, and the San Andreas. Goldfinger's team found proof that a magnitude 9 Cascadia earthquake can set off the San Andreas, and it has done so at least 3 times in the past 1,500 years. The study began with a mistake. During a 1999 research cruise, a graduate student typed the wrong coordinates, sending the ship 90 kilometers south of Cape Mendocino into San Andreas waters. Goldfinger pulled a sediment core anyway. That core held the first clue. Over 26 years and 5 research trips, the team pulled up 137 deep-sea sediment cores spanning 3,100 years, using carbon dating and CT. Scanning, they found earthquake-made layers on both the Cascadia side and the San Andreas side of Cape Mendocino. 10 of the 18 Cascadia events matched San Andreas events, and 3 of those pairs happened just minutes to hours apart. The most recent was tied to the known Cascadia earthquake of January 1700, the magnitude 9 event that sent a tsunami across the Pacific to Japan. Separate tree ring proof from Lake Merced in San Francisco dates a San Andreas break to the same window. Goldfinger told reporters it turns out there was also a 1700 San Andreas earthquake. The link point is the Mendocino Triple Junction, where 3 plates meet off Northern California. The Cascadia subduction zone ends here, and the San Andreas begins, split by just tens of kilometers. When Cascadia breaks, the stress moves south through the crust. Shock waves from a magnitude 9 event would cross Northern California in 4 to 6 minutes. Goldfinger called the scenario movie territory. San Francisco, Portland, Seattle, and Vancouver, all in an emergency at the same time. He added that he is from the Bay Area, and if Cascadia went off while he was visiting his hometown of Palo Alto, he thinks he would drive east. And the timing of what happened next was almost too perfect. Some scientists pushed back. Diego Melgar at the University of Oregon said what Goldfinger is showing is in no way a slam dunk. Greg Baroza at Stanford urged caution. But Melgar also agreed that if both faults broke at the same time, it would be a massive disaster. Even if the link happens 1 time in 5, rather than 1 in 3, it rewrites the risk math for the entire West Coast. The Cascadia zone last broke 326 years ago. The chance of a magnitude 8.7 or larger event in the next 50 years sits between 15 and 22%. The Federal Emergency Management Agency estimates a standalone Cascadia magnitude 9 would cause roughly 13,000 deaths and force 1 million people from their homes. That is the single fault scenario. Goldfinger is talking about the double. If that event sets off the San Andreas, no emergency plan in the country covers it. 2 months before Goldfinger's study went public, a Caltech team dropped a second piece of proof pointing the same way. On March 28, 2025, a magnitude 7.7 earthquake struck near Mandalay, Myanmar, killing between 3,000 and 5,000 people. But what made it a turning point for science was what the fault did. Researcher Solène Antoine and senior author Jean-Philippe Avouac at Caltech measured the break at 317 miles, the longest earthquake break ever recorded on land. Standard models had guessed about 155 miles for a quake that size. The actual break was more than double. It was also a super-seer event, meaning it moved faster than the shock waves it was making, like a sonic boom underground. Every bit of stored energy at every depth was let loose. The fault that made this break is called the Sagaing Fault. It is the same type as the San Andreas, a right lateral strike-slip fault where both sides slide sideways past each other. The Sagaing runs about 1,400 kilometers through Myanmar. The San Andreas runs about 1,200 through California. Similar length, similar slip rates, similar age. The match is, as the Los Angeles Times put it, eerily similar. The Myanmar break did not respect the section limits that scientists had mapped. It blew past zones that had already broken in 1930 and 1946, letting go of more slip than had built up since those events. This should not have been possible under standard models. Antoine's finding was firm. Earthquakes never come back exactly the same way. Sometimes it is quiet for a long time, and then, boom, you have a large earthquake. Avouac drove the California point home. The San Andreas could break all the way from Monterey to Imperial County, possibly topping magnitude 8. And he added that breaks on the same fault can release even more energy than the gap of slip since the last event. He is saying the earthquake could be bigger than the stored energy alone would suggest. If you are finding this useful, subscribe. We cover earthquake science and geography events like this as they develop. With the full picture, you need to follow what is going on. By 2025, the proof was stacking up from 3 separate directions. Fialco's satellite data said the fault is loaded. Goldfinger's sediment cores said it could be set off from 700 miles away. And Antoine's Myanmar study said it could tear farther than any model predicts. All 3 pointed at the same stretch of crust beneath Southern California. So what does that stretch actually look like? And who lives on top of it? The United States Geological Survey shakeout scenario, led by seismologist Lucy Jones, maps out a magnitude 7.8 earthquake starting at Bombay Beach near the Salton Sea and tearing 300 kilometers northwest, with shaking lasting nearly 2 full minutes. The expected toll, roughly 1,800 deaths, half from fire. 53,000 injuries, $213 billion in losses, 1,600 fires starting at once. All old brick buildings within 15 miles of the fault fully destroyed. At least 10 million people across 8 counties feeling heavy shaking. Desert Hot Springs, a city of 30,000, sits across 2 strands of the San Andreas. The fault runs right beneath mobile home parks, schools, and strip malls. A retired postal worker named Gloria has lived there 28 years and keeps her shoes next to her bed every night. She is not unusual. People along the Coachella Valley fault line describe a life built around a threat they cannot see but never quite forget. The way the water in a pool sometimes ripples for no clear reason, the way a kitchen cabinet door swings open on a still afternoon. The broader impact zone holds over 23 million people. The Coachella Valley alone, Palm Springs, Indio, and surrounding towns, holds about 370,000 year-round and over 600,000 in winter. San Bernardino has 226,000. The Inland Empire combined holds 4.6 million. And while the fault passes 35 miles northeast of downtown Los Angeles, soft ground basins in the San Gabriel Valley and East Los Angeles would trap and boost earthquake waves, creating heavy damage far from the fault itself. But the weak point that haunts planners most is water. All 4 pipelines feeding Southern California, the 2 Los Angeles aqueducts, the California Aqueduct and the Colorado River Aqueduct, cross the San Andreas a combined 32 times. A major break would cut all of them at once, shutting off more than 70% of the region's water. The Los Angeles Aqueduct passes through the 5-mile Elizabeth Tunnel 250 feet underground. A break would split that tunnel roughly 10 feet in each direction. The Colorado River Aqueduct, west of Palm Springs, could be lifted 13 feet, stopping flow completely. Lucy Jones has been blunt. We are the first city that has really bet its life on outside water. There is no way to not go over the fault. Full water return could take a year. During that time, water service in parts of Los Angeles would drop to 31%, crippling firefighting during the very fires the earthquake starts. If you are wondering how that is even survivable, so is everyone else. And the shakeout scenario was built as one realistic outcome, on purpose, not a worst case. Former Los Angeles Mayor Eric Garcetti warned that if it took 6 months to get the water system back, residents and businesses would be forced to leave for so long that they might never come back. Roads and rail are just as exposed. Interstate 10 and Interstate 15 both cross the fault. Cajon Pass matters most because the highway, a rail line, oil pipelines, power lines, and gas lines all cross within a tight space. Those rail lines carry much of the 40% of American imports that come through the ports of Los Angeles and Long Beach. In total, lifelines cross the San Andreas at 966 spots. The physics of why this cannot be diffused is called elastic rebound. Picture 2 people holding a rubber band looped around a fence post, walking in opposite directions 1 inch per year. The band stretches, the post holds. Then it snaps free, and all that stored energy lets go in an instant. That snap is the earthquake. The Pacific Plate moves northwest at about 46 millimeters per year, roughly the speed your fingernails grow. On the locked southern San Andreas, friction holds the 2 sides in place, while the rock on either side bends, like a stick being flexed further and further from center. When the stress finally beats the friction, the rock snaps back all at once. 335 years of built-up bending, released in roughly 2 minutes. A magnitude 7.9 event releases energy equal to about 700 Hiroshima-sized atomic bombs going off along hundreds of miles of fault line. And because the southern San Andreas has been storing energy longer than any past gap in its known history, the next event could top magnitude 8. Recent activity has kept the system in sharp focus. On December 5, 2024, a magnitude 7.0 earthquake struck off the coast of Northern California near the Mendocino Triple Junction, the exact spot where Goldfinger says Cascadia and the San Andreas meet. Stress study by Tembler found the event likely added stress to the northern tip of the San Andreas, near the end of the 1906 rupture zone. Real-time proof of stress jumping between faults, happening today, not in a sediment core from 1,000 years ago. The year 2024 was a record year for Southern California earthquake clusters, 15 separate clusters with at least 1 magnitude 4 event, the highest count in 65 years, according to Lucy Jones. Swarms hit Malibu in February and again in September, then El Sereno, Ontario, and Catalina Island. In November 2025, over 80 earthquakes rattled the Calaveras Fault near San Ramon in the Bay Area. Nobody saw this cluster of signals coming. Scientists are not panicking, but they are paying closer attention to the southern San Andreas than they have in decades. And the data keeps giving them reasons to. 3 separate lines of research from 2023 to 2025 now point the same way. Goldfinger's sediment record says the San Andreas does not act alone. It dances with Cascadia, and the 2 faults have broken near the same time at least 3 times. The Myanmar earthquake shows that old faults can break far longer and far harder than number-based models predict. And the Lake Kauai study says the fault may be more dangerous now because the water weight that used to help trigger it has vanished, leaving it locked with no natural release valve. None of these studies can tell us when. The fault does not follow a calendar. It only follows physics. And the physics says the same thing it has been saying for 335 years. The pressure is building, the stick is bending, and 23 million people are living on top of a system that has no off switch. The plates have not paused for a single one of those 335 years. The water pipelines that keep Southern California alive crossed the fault 32 times. And the science of 2025 says that when this fault finally moves, it may not follow the script anyone wrote for it. As of today, the fault is still locked, still bending, still adding roughly 1 inch of stored motion every year. This story is not over, not even close.